Hey guys, we are going to move on and start lesson 4.7. So let me present my screen and we'll get started. Okay, 4.7. All right, so we are going to be looking at polynomial functions and transformations of those polynomial functions. So to start, we just have vocabulary. Polynomial function, a function of the form f of x equals a sub n x to the n plus a sub n minus 1 times x to the n minus 1. So these are the polynomial functions that we've been studying. Here's an example, 3x to the third plus 4x squared plus 2x minus 1. All right, we know what makes it a polynomial function. We know that the exponents have to be whole numbers, coefficients have to be real numbers. All right, transformation of the graph of the function. When we transform the function, is going to change the size, shape, position, and orientation of the graph. Okay, the transformation rules, luckily, are very, very similar. Okay, they look very, very similar to our transformation rules with our quadratics. So here's the notation. Here's an example. But if you think about our quadratic functions, a times the quantity x minus h squared plus k, okay, we know the h, the k, the a, what they do to the function, moving it right, left, up, down, horizontal stretch, flipping it, all the same things here. All right, so minus 5 inside the parentheses is 5 units right, plus 2 inside the parentheses is 2 units left. Outside the parentheses, that's your k value, moves up 1, moves down 4. Okay, reflection. If the negative is inside the parentheses with the x, it's going to reflect over the y-axis. If it's outside the parentheses, that's when like the a value is a negative. It flips over the x-axis. It opens down, right? If you think about your quadratics, your parabolas. If we have a factor multiplied with the x inside the parentheses before we apply the exponent, that's going to either give us a horizontal shrink by 1/2. That's what that would look like. Or this is a vertical stretch, or excuse me, I said the wrong thing, horizontal stretch by 2. If it is in front of the x, so if it's not contained in parentheses with the x, so order of operation, you would evaluate the x to the fourth first and then multiply by 8 in this situation. That is going to be a vertical stretch or shrink. So if in this case, it would be a vertical stretch of 8. Here we have a vertical shrink of 1/4. Okay. All right. So for these, it says describe the transformation of f of x by g, then graph each function. You're going to use your graphing calculators for all of these, so I'm not going to take the time to graph every single one of them with you during this video lesson. I think we've graphed enough. I'll show you just maybe one as an example, but I think we've graphed enough that you should be able to graph them on your own. What I'm more concerned about or more interested in is making sure that you know what the transformation is, just looking at the f of x and the g of x. So we'll go through some of those together, okay? All right, so for the first one, the f of x function, the given function is f of x equals x to the fourth, and then g of x is x to the fourth minus 9. So I want to know, what did this minus 9, what did this subtracting of 9 do to the f of x function? Let me get rid of that little scribble on the paper, is bothering me. All right, so for number 1, hopefully we know it's going to translate down 9 units. All right. Number 2, the f of x is f of x equals x to the fifth. The g of x is x plus 1 raised to the fifth plus 2. So we have 2 transformations here. What does the 1 do? What does the 2 do? All right, the 1 translates 1 unit. Which direction, right or left? What do you think? Left. And the 2, we're going to translate, we're going to move, we're going to slide 2 units up. All right. All right, the next one. So f of x equals x to the 6, g of x equals negative 5 x minus 2 raised to the 6. So we have 3 things to talk about: that negative, this 5, and this minus 2. Okay, so that negative is a reflection. Is it a reflection over the x or the y? It's going to reflect over x-axis. That 5, is it a vertical, horizontal, stretch, or shrink? That is a vertical stretch by 5, by a factor of 5. And then that minus 2 inside the parentheses, we're going to translate 2 units which direction? Up, down, right, left. Right. Okay. All right. And then we have f of x equals x to the third, g of x equals 1/2 x raised to the third minus 4. All right, so we have to talk about that 1/2. What's that factor doing? And the minus 4. What's that factor doing? Okay, so the 1/2 in the parentheses with the x. So think about this for a second. Is it a vertical or horizontal, stretch or shrink? And by what factor? This is a horizontal stretch by a factor of 2. And that minus 4 on the tail end is going to translate 4 units down. All right. Any questions on those? Okay, let's keep moving. I asked if there are any questions, like I could hear if you asked any questions. I'm just so used to saying that. If you have any questions, you can email me. All right, number 5 and 6. So we have f of x equals x to the fourth, g of x equals 1/8 times negative x raised to the fourth. So we're going to talk about that 1/8 and that negative inside parentheses with the x. All right, so the 1/8 is a vertical shrink by 1/8. And the negative inside the parentheses with the x is going to be a reflection over y-axis. All right. And the next one, we're going to talk about that minus 10 and the plus 1. That's going to translate 10 units, which direction? Right, left, up, down. Right. And the 1 is going to translate 1 unit, which direction? 1 unit, sorry, no S there. Up. 1 unit up. All right, so I said I would graph one of them. Let's just go back. We'll go to number 6 since it was the last one. Let me pull up my graphing calculator. Okay, so I'm going to plug in both functions. I have x to the 5th for the first one, x raised to the 5th. The second function is, I don't think I have it in front of me. Oh, I do. It is parentheses, x minus 10, close parentheses, raised to the 5th, plus 1. And we're going to graph. So the parent function, the original is blue, and the new is red. Okay, and I might want to change my window. I'll just change my X max. Right now I can only see over 10 units. Maybe I'll just shift it and say 15. And yeah, that's fine. I'll just do that. Oh, I need to go over more. I didn't think I would need to. Let's see. I'm going to change. Oh, well, that's because I changed the Y instead of the X. That's why. I need to change my X max to 15. I changed the wrong axis. Try that again. There we go. That's what I was expecting to see. I just changed around one. Okay, so the blue is the original, the red was the new. And we said for that one that it shift 10 units to the right and one up. Does that look accurate? Does it look like it moved 10 units to the right and one up? Yeah, that looks good. Okay, so, and if I needed to graph this by hand, or if I wanted to know some good points to help me sketch it, I could just go second table, and then the black x-axis or x value with the blue y value, that would graph your blue function, and then the black x value with the red y would graph your red function, okay, your new transform function, okay? All right. Oh, I didn't want to close that. Oh, well, that's okay. All right, so here it says graph the function g of x equals negative f times x minus 3 on the same coordinate plane as the f function. Oh, sorry, I'm getting tired. Okay, so let's talk about what transformations that's saying. They're saying for the new function, they want you to take this function that's given and perform these two transformations. That's how you kind of have to read it. So again, for my new g of x function, I want to take the f of x function, but I want to perform these transformations, which it says negative f x minus 3. So what does the minus 3 inside the parentheses do to the function? What does the negative outside do? Well, the minus 3 inside means I'm going to translate 3 units, which way, right or left? Right. And the negative means I'm going to reflect over the x-axis. Reflect over x-axis. So if I just like plot a point or two, maybe I talk about this point here, and this point here. I'm going to move each point 3 units to the right and then flip it over the x-axis. So move this point 3 units to the right, 1, 2, 3, and then flip it over the x-axis. Move this one 3 units to the right, 1, 2, 3, flip it over the x. And this one, 1, 2, 3, and since it's on the x, it doesn't go anywhere when you flip it. And this would be your g of x function. Okay, so again, it says graph the g of x function on the same coordinate plane as the f of x function following these transformation rules. Okay, I know the notation's a little kind of tricky to understand what you're supposed to do for that problem, but hopefully that makes more sense now. All right, and let me just see how many more I'm going to do. Okay, for exercises 8 and 9, write a rule for g, then graph each function. Describe the graph of g as a transformation of the graph of x. Again, these are graphing calculator problems, so the notation for this looks similar to what we just saw up here. So hopefully it kind of makes more sense. So they want you to perform these transformations to the f of x function in order to get your g of x function. So this notation is telling you to change the sign of x and then subtract 9 off the tail end. It's telling you to reflect it over the y-axis and move it down 9 units, okay? So for my g of x function, I need a pen. I'm going to take the f of x function, but where I see x, I'm going to make it negative because that's going to reflect it over the y-axis. And then on the tail end, I'm going to write minus 9 because that'll shift us down 9 units. Now I'm going to clean it up, right? So if I have negative x cubed, that's a negative times a negative times a negative, it's going to stay negative. So it's negative x cubed. And then plus 8 minus 9 is going to simplify down to a negative 1. Okay, so that is your g of x function. And it does say to describe the transformation. Well, we already talked about it being a reflection in the y, move down 9 units. So reflection or reflect over y-axis, and then translate down 9 units. Okay. Number 9. So they're telling you for your g of x function, take your f of x and multiply the entire thing by 5. So I'm going to multiply this entire thing by 5 to get my g of x function. That's what this notation says. So for g of x, I'm going to have 5 times the quantity of 2x raised to the 5th minus x cubed plus 1. Now, before I clean it up, what does that number out in front of the f of x telling you to do? Is it a vertical stretch, shrink, horizontal stretch, or shrink? That is a vertical stretch by 5, by a factor of 5. All right, I'm going to distribute that 5 in now that I know what to do and I've talked about the transformation. So it's 10x to the 5th minus 5x cubed plus 5. So there's your function, your g of x function, and here's my description. And then you could use your graphing calculator to graph the f of x and now the g of x. Okay. All right, and 2 more and then we're done. Okay, so it says in exercises 10 and 11, write a rule for g that represents the indicated transformation of the graph of x. So basically the same thing we were just doing, but instead of notation that we have to figure out how to write as a transformation, they're just going to spell it out and we have to put the right signs or numbers in the right spot. Okay, so it says translate 1 unit left. Okay, so if we translate 1 unit left, is that number usually inside the parentheses with the x or outside? Is it a -1 or a +1? It should be a +1 inside the parentheses with the x. So everywhere I see an x, oh, I need a pen. Everywhere I see an x, I'm going to put a -1, or sorry, a +1, because left 1. So for my g of x function, to get started, we're not going to be done yet, I'm going to write x plus 1 cubed, right? Because now I know that I'm moving 1 unit to the left, minus 6, and then inside this x, I also have to do x plus 1 squared plus 5, okay? Followed by a reflection in the x-axis and a vertical stretch by a factor of 2. All right, so a reflection in the x-axis means the negative should go out in front, and a vertical stretch by a factor of 2 means the 2 should go out in front. So I can do it out in front of the entire function, okay, or out in front of this parenthesis and that parenthesis, but then you also have to multiply that by -2 as well. So the easier way of writing it for now is -2, and then maybe a bracket, x plus 1 cubed minus 6, x plus 1 squared plus 5, and then an enter bracket. All right, I'm going to distribute the -2 in, so it's -2, x plus 1 cubed, distribute the -2 in, so plus 12, x plus 1 squared, distribute the -2, minus 10. Okay, and that would be it. Now, honestly, I would take it without you distributing the -2 in. So if you left it in that form, I would take it like that. Or a more simplified answer, distributing the -2 in would look like that. I'm not going to make you multiply out the x plus 1 cubed and multiply out the x plus 1 squared, simplify it. Although we could, we're not going to. We'll just leave it like that. Okay. And the last one. So just like this one, take it step by step. Do one transformation at a time, okay? Because they're written in a specific order on purpose. So first it says a horizontal horizontal shrink. So horizontal, I know it's a reciprocal. I know it's inside the parentheses with the x. So horizontal shrink by a factor of 3. And a translation units down, okay? So let's do the horizontal shrink by a factor of 3 first. So inside the parentheses with the x, I'm going to have a 3x to the 4th. Inside the parentheses with the x, I'm going to have a 3, then x to the 3rd. Inside the parentheses with the x, 3x, and then squared, and then plus 12. Okay, now I can clean that up. All right, if I evaluate, so 3 to the fourth and x to the fourth, that's going to be 81 x to the fourth. Okay, 3 cubed and then x cubed, so that's going to be 27 x. Oh, do I want to do that? You know what? I'm not going to simplify it yet. I just saw something else that we're going to have to do, and it'll make more sense if I wait. But don't simplify it quite yet. All right, so let's go on to the next transformation, which says translate 8 units down. So 8 units down to me, I'm going to subtract an 8 off the tail end. And then finally, a reflection in the y-axis. Reflecting in the y means that inside the parentheses with the x is where the negative goes. And this is why I decided not to simplify quite yet. Okay, the negative there is going to take care of the reflection in the y-axis. Now I'm going to clean everything up. All right, so I'm going to have 3, and then I'm going to have negative 3 raised to the fourth, which is a positive 81, x to the fourth. And then negative 3 raised to the third is a negative 27, x to the third. Negative 3 squared is a positive 9x squared. And then we can simplify 12 minus 8 will give you your 4. All right, another step more to simplify. 3 times 81 is going to be 243 x to the fourth. And then I can clean up the signs here, make it minus 27 x to the third. And then multiply here to get a positive 27x squared. And finally a plus 4. Okay, so think about each of those transformations. Make sure you understand how I got this first step. Because once you get the first step, it's just cleaning up with some Algebra 1 skills. All right, guys, I believe that is the end of this lesson. Let me go back to our main screen. All right, yes, that is the end of lesson 4.7. I'll see you back here for the next one. Bye.